Hey, welcome to the last part of geometry. We're doing area, volume, and surface area, basically. But first, I'm going to remind you of some area formulas that you should have learned sometime in middle school, but maybe forgot. So we're just going to do those couple, I think it's 3 area formulas, and then we're going to practice those. And then next time, we're going to do segments of area, so like half of a triangle, etc. Okay? So first of all, area of a circle is pi r squared. Here's my perfect circle. And the radius, the r is the radius. That's from the center outwards. So that's the radius. Is halfway across a circle. Pi is just pi. Don't change it for 3.14. Just use pi usually. And then, so the radius squared times pi is our circle. The area of a triangle is 1/2 base times height. There we go. I don't know what I was starting to write. 1/2 base times height. And so if I do half of the base times the height, or even half of the height times the base, I'll get the area of the triangle. I feel like I'm cool, but I'm not. The height is straight down from the top to the bottom. It's also called the apothem, which is really weird. But that's the height, and then the base is the base. Now, here's the fun thing. I don't know. If I turn this triangle like this way, let me see if I can do this on here. Yeah, this could be the base, and this could be the height. Okay, so if I'm only given these 2 numbers, I could do the same math, just with this as the base and that with the height, as long as this is a right triangle. All right. So rectangles are pretty easy. It's just base times height. But why do I have a plus by it? Because if I push it over, it's the same math still. So I can do base times height for anything that's kind of like a rectangle. Okay. So if I take this section off and I move it over here, right, this will be the same as a rectangle. So that's why I called it rectangle plus, because I can do still base times height even if I move part of the parallelogram over. Oh, and this works for regular trapezoids too. Where am I going to put this? I didn't plan ahead well enough. Let me draw it. Hold on. Okay. This would be the base. And if I cut this part off, I can put it over here. So it also works for trapezoids as long as they're normal side. What I mean by normal is like this section and this section are the same. If it's like slanted, it doesn't quite work that way. We have to do something else. But, all right. So all these things work for rectangles. And that's pretty cool. All right, we're going to do all of these, so I just drew them out so I didn't have to sit here and think about them. But if you want, you can pause here and try them and then see what you get. Welcome back. Okay, so we're going to do, this is a circle, so we're going to do pi r squared. So we're going to do pi times the radius squared, which will be just 9 pi. We don't need to write, do 9 times pi in geometry. Welcome, you've made it. If you wanted to, it'd be like 19 point something or 18 point something, because 9 times 3 is 18, so a little bit higher than 18. But no, 9 times 3 is 27. Don't show anybody this video. I promise I know what I'm doing. Okay, so 9 times 3 would be 27, so a little bit more than 27 would be this actual, but this is fine. Oh, and we want to use units. Shoot. Inches. I'll just do that one with units. But all these are going to have square units as the area. Maybe I should have done that. Hold on. Okay, we fixed it. So 3, whatever the units are, be units squared, because we're finding the squares inside of the shapes, basically. Okay, so now 7 is the diameter and not the radius. So if 7 is the diameter, the radius is half the diameter. Okay, so my radius is actually going to be 3.5. So we're going to do pi times 3.5 squared, which I should have color coded because I color coded the last one, by golly, which isn't a nice number, but we're still going to leave the pi normal attached to it. So that's going to be 12.25 pi, and this is inches, so it'll be square inches. And yes, I know we're silly because we say the squared first and then the units, but it's okay. All right, let's move on. This is a triangle, so I'm going to do 1/2 base times height. Base is going to be 2. Height is going to be 5. So I can do this a couple different ways. What people normally do is they'll do these two numbers multiplied together first and then find half of that. So 2 times 5 is 10. Half of 10 is 5. You can also do a half of 2 times 5. So half of 2 is 1. 1 times 5 is 5. Or you can do half of 5 and then multiply that by 2. Half of 5 is 2.5 times 2 is 5 again. But in any case, that's 5 feet squared. So we don't write the feet symbol anymore. We have to actually write feet squared. Otherwise, it looks like 5 feet that have been, or 5 to the power 12 or something. It would just look really silly. All right. These are both inches, by the way. I'm not going to, this is what you should have learned already. So I'm just doing a reminder before we get into the hard stuff because I want to make sure you're at the same level. So I'm not going to make this like inches and feet or anything like that. But what I am going to do is here, this is a obtuse triangle. So it shows you the base and it shows you the height kind of chilling out over here. So we're going to do 1/2 times base, which is 3, times height, which is 3. Now, this isn't going to be a nice number, but it's going to be okay still. Because 3 times 3 is 9, and half of 9 is 4.5. And that's square inches because it was in inches before. All right, and then here we have a rectangle, a standard rectangle. This is nothing crazy. So we're going to do 10 times 7, which is 70. So I actually have to show you my work, though. And this is square meters. And then here, I'm going to do, this is base is 15, height is 12. So I'm going to do 15 times 12, which I should have done ahead of time. $180, obviously. I almost did degrees because I'm so used to 180 degrees being a thing that's important. So that's 180 square inches. All right. Listen, I'm just going to repeat myself one more time. Yes, this is easy stuff, okay? This feels like I'm teaching middle schoolers again, but I'm not. And the reason why I'm not is because in the practice, I'm going to try to trick you a little bit, just a little bit. And then next time when we start doing partial parts of these figures, then it's going to get a little more challenging. I just need you to have a nice, solid foundation. You're welcome. All right. See you soon.